2013 problem 4. The figure shows the graph of f prime. That right there is really important, so you get on the right level right away. If you were to think that was f or f double prime, you'd be in big trouble. Derivative of a twice differentiable function, so no weirdness. On a closed interval, f prime has horizontal tangent lines at these three locations. Here they're just being clear. They're trying to make sure that you don't feel tricked by anything. So that, for example, is a relative maximum because the derivative is 0 there. Let's see, the area of the regions between the graph of f prime and the x-axis are labeled in the figure. You may notice, for example, that this does not say area equals -3, even if you might be thinking that. Area itself is a geometric concept and is non-negative. It's your job to do the calculus thinking that the corresponding value of a definite integral from x equals 4 to 6 will be -3. And it says the function f is defined for all real numbers and satisfies this initial condition. Of course, we'll use that later. A, find all values of x on the open interval from 0 to 8 for which the function f has a local minimum. B, determine the absolute minimum value of f on the closed interval 0 to 8. Justify your answer. This has to include the endpoints in consideration. You do not have to consider x equals 4 because that's the location of a relative maximum for f. So what the readers will be looking for is that you consider x equals 6 and then also the endpoints. This requires some thinking. When they give you an initial condition, and I did call it an initial condition, I mean it is, but it can be a bit confusing because it really comes at the end of the x interval in question from 0 to 8. So you really have to work backwards. And if you look at the rubric that AP gives you, they start with plus, and they're just formulaically following the most important sentence in the class, which is initial condition plus net change. For me, I just really prefer to think about the question in this way. There's one other major issue that you have to consider when working the problem as opposed to what you see in the rubric, and I'll show that to you right now. Probably the most common mistake a person would make is to fail to group this entire expression. Anytime you have a minus, this can be very dangerous for grouping and getting the wrong sign. If you fail to have parentheses, for example, you would just have the wrong answer. And in the rubric, that doesn't really show up. They just sort of show this clean, perfect answer. So for you, when you're trying to complete these problems and get right answers, it really helps if you write the minus and then open a parentheses. This means that you can just turn your brain off and not think about what effect this subtraction will have on anything. And now these are just straightforwardly the values of the integrals that correspond to areas under the curve. Now, ordinarily I would not simplify, but here I feel like I should because I want to know which one is smallest. So I'm going to simplify. It's important that you answer the question. They did not ask you determine where the absolute minimum value occurs. If you read the directions carefully, it says determine the absolute minimum value. So I've answered the question. That's a y value essentially. Part C, on what open intervals contained in 0 to 8 is the graph of f both concave down and increasing? Explain your reasoning. So f is increasing whenever f prime is positive. So that means that we are only going to consider values of f prime that are above the x-axis. And then f is concave down when f double prime is negative. So we're looking for where f prime is decreasing. So for example, here, here, and this is out because f prime is increasing on that interval. So we have the two intervals. They run from 0 to 1 and from 3 to 4. Part D, the function g is defined by g equals f of x cubed. If f of 3 is this, they just tell you, find the slope of the line tangent to the graph of g at x equals 3. So you don't actually need a whole tangent line, you just need the slope. So that means that I'm going to need g prime of x, and then I can plug in 3 and hopefully get an answer. Power rule, chain rule. Now I should be able to plug in. Let's see, when x is 3, f prime of x is 4. No need to simplify, and the problem's over.